Hello guys, welcome to my channel. In today's video I'm gonna go over how to find the limit of a function at infinity. We're gonna go over some basic functions and then we're gonna solve some examples like these. So we're gonna solve these examples. Okay, this one and this one. Alright, let's go to the basics. So first of all, let's say you got x and x approaches to infinity. That's obvious. The limit of this function is going to be positive infinity, and if it's approaching negative infinity, then it's going to be negative infinity. Okay, and if we got function x square and x approaches to infinity, and the limit of this function as x approaches to infinity, it's going to be infinity square, gives me just positive infinity. And if it's going to negative infinity, and again there is a square, so we are approaching towards the negative side. The square of any negative number is positive. So even though x approaches to negative infinity, the answer or the limit of this function is going to be positive infinity. And now let's look at if we got 1 over x as x approaches to infinity, or as x approaches to negative infinity of 1 over x, or we got 1 over x square as x approaches to infinity, or x approaches to negative infinity for 1 over x squared. To go over this, let's look at the graph of these functions. Let's look at the graph of 1 over x. So if I'm graphing 1 over x, so the graph of 1 over x looks like, like this. Similarly on this side. Okay, so it's keep going towards as x is approaching to infinity either side. See, this is my positive infinity side, this is my negative infinity side, so x and y. So as x is approaching towards the positive infinity, you see the value of the y, the value of the function is going towards 0. The graph is almost touching the x-axis, so we are getting horizontal asymptote there. So that means the value of the function as x approaches to infinity is 0. And if you look into the negative infinity side, same thing, the function is approaching 0. So the limit as x approaches to infinity for 1 over x is 0, and also when limit of x approaching negative infinity of 1 over x is also 0. And now look at the graph of 1 over x squared. So this is graph for f of x is equal to 1 over x. Let me graph x negative infinity, and this side we are approaching towards positive infinity, and the function is 1 over x squared. So the graph of this function looks like this, and on this side. Okay, so if we see as x approaching positive infinity, the value of this function, which is 1 over x squared, is approaching towards 0. Okay, so the limit as x approaches to infinity of 1 over x squared is 0 again. And similarly, as it's approaching negative x, again the function is dropping down, going down, and almost going towards the 0 at infinity. So the limit of 1 over x squared as x approaches to negative infinity is also 0. Or in general, we can say the limit of, let's say, constant c over x raised to power n as x approaches to infinity is going to be equal to 0. Alright, so let me make some space here. We're gonna go over a rule like how to find a limit of a function as x approaches to infinity. We're gonna use this formula, these formulas in that, but before that let me go over one simple rule. Okay, so let's say we got a function let me write the easiest function. So we got limit as x approaches to infinity. I got ax square plus bx plus c over, let's say, dx square plus ex plus f. So first of all, what we need to do is we need to write the function in the format. We need to write the function in the format like f of x over g of x as a rational function. If it's not, like in this case, it's already written in f of x over g of x. If it's not, then we need to write in this format. That's the step one. And step two, we need to divide numerator and the denominator by the highest power of x. Okay, so in this case, the highest power of x in numerator and denominator is x square. So we need to divide the numerator and denominator by x square in this example. So in this case, we get limit x approaches to infinity. We got, when we divide this by x square, we got a plus b over x plus c over x square. And same thing in the denominator, we got d plus e over x plus f over x square. And then the step 3 is just solve it, plug in the value of x there, and you'll find the limit. So as x approaches to infinity, this gives me a constant stay the same, but the limit of b over x as x approaches to infinity, and we know, is equal to 0. So 0 plus c over x square, c raised to power n, any value of n, constant over x raised to power n value, always 0. So this is 0. And in denominator we got d, and the limit of e over x is 0, and you can see 1 over x, the limit as x approaches to infinity of 1 over x is 0, and x square is also 0, so we got 0. So basically, limit of this function as x approaches to infinity is a over d. Alright, let's do a couple of more examples, then it will make more sense. Okay, so let's go over a few examples over here. So we got limit x approaches to infinity 6x plus 8 over 3x plus 4. So as we know, this is already in this format, f of x over g of x, because that's our first step, but this is already written as a rational function. The second step is divide numerator and denominator by the highest power, or the highest degree of x. In this case, it's just x. So dividing numerator by x gives me, let me write it down, limit x approaches to infinity. So we got 6 plus 8 over x, and in the denominator we got 3 plus 4 over x. So that gives me 6, and limit as x approaches to infinity of 8 over x is 0. And same thing, 3 plus 0, which is equal to 6 over 3, which is equal to 2. So that's the answer. Let's go over the second case over here. So here, limit x approaches to infinity. The first rule is write in the format fx over gx, which is there, and then divide by the highest degree of x. So here it's x square. Okay, so we're gonna divide the numerator and denominator by x square. So what you will get, so I got 2 over x plus 3 over x square, and in the denominator I got 1 minus 4 over x square. Okay, so the limit of this function as x approaches to infinity is going to be 0, and x square is also 0, and here we got 1 minus 0, so that gives me 0 over 1. So the limit of that function is basically 0. Let's work on this one. So limit x approaches to infinity, and it's already written in fx over gx, and now gonna divide it by the highest power of x, so which is x square. So what we'll get in the numerator, we got 3 plus 4 over x minus 2 over x square, and in the denominator we got 1 over x minus 5 over x square. So what we are getting here, in the numerator we got 3, and this 4 over x gives me 0 as x approaches to infinity, and negative 2 over x square as x approaches to infinity gives me 0. And in the denominator I got 0 minus 0. So we are getting 3 over 0. So in this case, something over 0, and we all know which is equal to infinity. So that tells me the limit is undefined in this case. All right, so what did we learn in these three examples? So let's say if the degree of the numerator is greater than the degree of the denominator, which is this case over here, if the degree of the numerator is greater than the degree of denominator, then the limit of the function as x approaches to either positive or negative infinity is undefined. Okay, and if the degree of the numerator is smaller or lesser than the degree of the denominator, which is this case, so as x approaches to plus or minus an infinity, then the limit of this function is always equal to 0. Okay, so if the degree of numerator is less than the denominator, the limit is 0. If the degree of numerator is greater than the degree of the denominator, the limit is undefined. And if the degree of numerator and the degree of denominator is equal, then we use those algebraic steps to find the limit of a function. Okay, so you can find the degree of a function even without solving it if you see any of these cases. Okay, so let's do a couple more examples, then you will see what we are doing here. Okay, so we got limit as x approaches to infinity, 2x minus 3 over square root of 3x squared plus 9. So as this is already written as a rational form, fx over g of x, so what we're going to do, we're going to divide the numerator and denominator by the highest power of x. In this case it is x. Here it looks like x squared, but we got square root on it, so it's basically x. So we're going to divide the numerator and denominator by x. So what we get over here, we got 2 minus 3 over x, and in the denominator we got 3 plus 9 over x squared. So it's basically 1 over x, but as I take x inside, it will become x squared. So it will be 3 and 9 over x squared. And now just solve for the value, solve this function as x approaches to infinity. This gives me 2 minus 0 over square root of 3 plus 0. So the limit of this function is 2 over square root of 3. All right, now let me go over this step again. Okay, so let's see. So 2x over x, right, minus 3 over x. Gonna write limit x approaches to infinity. So over here we got 1 over x of 3 plus 9 over x squared. Oh, sorry, what I'm doing. 3x squared plus 9. Okay, so this gives me 2 minus 3 over x. Can I say limit x approaches to infinity, and as I take this x inside the square root, it will become x squared. So we got 3x squared over x squared plus 9 over x squared, which is basically limit x approaches to infinity, 2 minus 3 over x, and you got 3 plus 9 over x squared. So that's how we got this. I just want to go over it if you are confused like how we got this. All right, let's do one more example. So in this case, our function is not written in fx over gx format. So what we need to do, first of all, we need to write this function in fx over gx form. So what we're going to do here, like as we did before for rational functions, we're going to multiply it by its conjugate. Okay, so it will be x squared plus x plus 1 plus x squared plus 1, and as we are multiplying we need to divide by same number, x squared plus x plus 1 plus square root of x squared plus 1. Okay, and now on the numerator we got, you see, a minus b into a plus b, which is basically equal to a square minus b square. So limit as x approaches to infinity, so this square minus this square, so that's what we get from this identity. So we got x squared plus x plus 1 minus x squared, and this minus get distributed over there, so we got minus 1, and in the denominator we got x squared plus x plus 1 plus x squared plus 1. Okay, and when we simplify, x squared cancel this x squared, 1 cancel this one, so in the numerator we got only x, and in the denominator we got this. So as you see, the highest degree in numerator and denominator is x, so we're going to divide the numerator and the denominator by x. So limit x approaches to infinity, as we divide the numerator by x, so x over x gives me 1, and in the denominator I got 1 plus 1 over x plus 1 over x squared plus 1 plus 1 over x squared. So in the numerator, as we plug in x to infinity, or as x approaches to infinity, so we got square root of 1 plus 0 plus 0 plus square root of 1 plus 0. Therefore we got 1 over 1 plus 1, 1/2. So that's the limit of this function as x approaches